from a wetter area, we just have to go a few hundred meters up the mountain. And if we want to collect seeds which are genetically adapted to a drier area, we just have to go down the mountain a few hundred meters. So working on a mountain, it compresses the geographical space, if you like, and makes doing this composite provenancy much easier than travelling up and down the lines of latitude. We bring the seeds into the nursery. We've done dozens and dozens of experiments, lots of graduate student experiments on trying to get them to germinate. Different seed preparation treatments, different media, different fertilizer regimes, and so on and so on. We've managed to grow about 450 indigenous forestry species in our nursery to date. And then, of course, the next step is to take these species that are grown in the nursery and do field trials. We've got field trials now operating in several different countries and a lot in around Chiang Mai. In the field trials, our main interest is comparing the performance among the species. Which species are actually functioning as framework tree species and which species are not. We also test silvicultural techniques. We have this high technology circle of cardboard underneath the tree here. And that mulch will prevent weeds from growing up immediately around the tree. It will also improve the moisture retention and the soil quality underneath around the tree as well. And it also stops the fertilizer from being washed away. The third reason why we do these field trials is, of course, to monitor the return of biodiversity into these areas. So now, after all these research in the nursery and in the field and in the natural forest, we have a fairly good idea of what tree species actually function as framework tree species. So this is a spondias, produces wonderful fruit for deer and monkeys, and this is an acrocarpus, it's a legume. So it fixes nitrogen in the soil, and this is a fig tree. Fig trees are great for attracting wildlife, and their root systems also break open the soil and get more oxygen and water draining through the soil. Fig species are wonderful. How am I doing for time? What I'm really saying is, how long to go before coffee break?
10 minutes.
Carry on. Because next slide's my last slide. So we have effective restoration systems for several forest ecosystem types. We've done this in the north for evergreen forest, for deciduous forest. We've done it in Kanchanaburi for the bamboo deciduous forest. We've done it in Krabi for the Noctail Leo Tongdam. You know that one? Noctail Leo Tongdam. Conserving Thailand's rarest bird species. We've even done it in Cambodia and in China. These are the results. This is what most of our deforested areas look like. You know, we have a few scattered remaining trees up here. Most of it is covered in weeds, and then you've got some small trees regenerating naturally. And we take these areas, and within 2 years we can make them look like that. Now, the key to doing this are really three things. First of all, planting the right species. We spent a lot of time trying to figure out what species will grow up and look like this in 2 years. Secondly, planting stock quality. You have to produce trees which are 30 centimetres tall by the optimum planting time, disease-free and growing vigorously. And thirdly, you have to take care of the trees, the weeding and the fertilizer application 3 times in the first rainy season, 3 times in the second rainy season. By the end of the second rainy season, the trees are taller than the people who planted them, and they're closing canopy, and the weeds are beginning to disappear. You can walk away from the system, and the system will take care of itself. 2 years. By 8.5 years, everything looking like a natural forest ecosystem. So you've got an understory, some trees, natural trees coming up. You've got an overstory, which is up here somewhere. You've got dead wood there sitting on a log. Already some of the trees are dying and falling over, and they're putting dead wood into the system. So you've got your termites and your skinks and your fungi are coming back with the two. And the carbon, we've had students working on the carbon accumulation in these areas. The carbon accumulation is chugging along quite nicely towards climax forest systems. The structure of the system goes back. Remember the cartoon diagrams I showed you? Here are the pioneers. Here are the climax species chugging along underneath, and then there are others, the seedlings. Natural seedlings are too small to register on the profile diagram. So this is 6 years old. Structure is coming back. And biodiversity returns to these plots as well. When we started our work, we had about 30 bird species in the area. We did a pre-planting survey. Within 6 years, there were 87 bird species coming back. So we were then interested to understand, are these bird species which prefer primary forest, or are these bird species which prefer open areas? So we did a bird survey in natural forest, and we found that 63%, 2/3 of the bird community that like to live in natural forest were coming into our plots. So a 2/3 recovery of the bird species richness in about 6 years. Now people ask me, Steve, when do you know that you've finished restoring the forest? And I say to people, don't ask me, ask the birds. 2 out of 3 birds agree that this is good forest, right? Ask the birds. We planted 30 framework tree species into these plots, and 72 additional tree species came in. Most of them were dropped by the birds, dropped as seeds by the birds, which I've just shown you, within 8 to 9 years. So we're not counting seedlings of the species that we planted, so there's 30 species that we planted, plus another 72 species. So totally, there are 102 species of tree, which is really very tiny plots. In the whole of evergreen forest, over the whole of Doisset is 325 species. So again, we have 1/3 of the tree species coming back into really quite tiny experimental plots. So, the science works. We can put back forest ecosystems. We can put back forest ecosystems that have many of the resilient characteristics, the diversity and the encouraging mobility, these characteristics that we need to adapt forest ecosystems to the future. But the problem is, it is very hard work to do this. This is planting day, and everybody is happy, and they're digging their holes, and they're planting their 30 tree species, and people look good, and the television cameras are there, so everybody's doing their Facebook pictures. But try asking people to come back 3 times in the rainy season, and then do fire to put on the fertilizer, to do the weeding, and then 3 times the following rainy season, and then they have to do fire prevention as well, so they have to dig a fire break around these things. It's incredibly difficult. It's incredibly hard work. In order to implement the framework species technique, you have to gather the seeds of 30 different tree species from natural forest. So you have to have an area of natural forest nearby from which to collect your seeds. Now the 30 species that you have to collect, they are fruiting at different times of the year. So somebody from the local community or the local forest office has to go into the forest with a pair of binoculars and scan the trees and figure out which ones have got fruit, which ones haven't, are they framework species, are they not, and they have to collect the seeds of the framework tree species. That's not easy. We've tried to do this with many communities, and the weakest point in the forest restoration process is not enough people know the names of enough trees to be able to go into the forest and collect the seeds at the right time of the year. They might do it for 1 or 2 months, and then they get bored, and then they don't bother anymore. So the seed collection programs fail, and we end up with nurseries which tend to be filled up with the first 2 or 3 species that they found in the forest, and then they get bored and stop. Setting up community nurseries, it takes between 12 to 18 months to grow these trees in a nursery. Not only are local people a bit bored with having to wait so long, but the sponsors are bored as well. And this is the biggest problem. You know, we had a sponsor come along in May and said, oh, we've got money, we want to plant trees, June. Yeah, but that's only 1 month. How are we meant to grow 30 species of trees and plant them by June? And, you know, so people tend to go along to the forestry department and just grab anything and just put it in the ground just to get the money. Well, and then they die, and then the same area is planted the following year. So these are human, these are not technical or scientific problems, these are human problems. This is one of our community nurseries that we put into one of the schools on Adonis John Messinol.